Hello, hello, hello. This is Goodness Opera, bringing you another episode of Creating with Composites. Today we're discussing the recycling of composites. Um, Particularly, we're talking about end of life uh, EOL management. Okay, EOL stands for end of life, and it simply refers to products made using composites that have served their design life and are now being considered for recycling rather than being dumped in landfills and constituting all kinds of environmental difficulties. How to manage them, how to extract, recover the materials from the polymer composites. Of course, when I talk about composites, I'm referring specifically to polymer composites, fiber reinforced polymer composites like carbon fiber, reinforced epoxy, glass fiber reinforced epoxy or polyester or sometimes polyurethane or even vinyl ester or vinyl ester, depending on whether you're American or not. Um, so traditionally, composites have been considered to be unrecyclable, and one of the reasons for that is the difficulty with which the fibers can be extracted. And when you extract them with mechanical methods like grinding, that tends to damage and shorten the fibers, making them far less useful. And when you extract them using pyrolysis, which is a thermal technique involving high temperatures, that usually takes away the polymer. The polymer can be recovered through a kind of distillation process, and those chemicals can be used to for other purposes. But the fibers end up being left behind in that process, and that's one way that fibers have been extracted. But the problem with this technique is that the fibers tend to the fibers lose a lot of their mechanical strength and other properties in that high temperature process. So other techniques have been considered for extracting these materials. Over the years, it's been considered more or less an unrecyclable material. But fairly in recent years, we've had a lot of work. Well, over the years, there's been a lot of work on solvolysis, which is a blanket term that refers to a bunch of different processes that involve the use of a solvent um, under high temperature, pressures. And the whole idea is to break down that material under those conditions in a solvent, in a suitable solvent. So sometimes water can be the solvent, and that would then be called hydrolysis. If it's methanol, it can be called methanolysis, and so on and so forth. There are many of such processes. Um, Aminolysis, uh, there are a bunch of them. So solvent recovery seems to be the leading technology for extracting these fibers at this time because they allow the extraction of fibers which are still somehow able to retain um, a good percentage of the mechanical properties they had as virgin material from the in the beginning. So this is an important development, and this discussion also proposes something that can be done with these end of life materials. Now, what materials are we referring to exactly? What products are we talking about in terms of, what products are we considering for this? Now, if you look at various products made using composites like pipes, boats, wind turbine blades, um, car body panels, there's a wide range of products that are made using composites, aircraft parts. Um, Very large quantities of composites are used to make these materials, And when they reach the end of their design life, it's a concern. What it's an important thing to look at what can be done with these materials, because they are produced in very large quantities, and so throwing them in the landfill will constitute a really serious problem. So these are the materials, particularly wind turbine blades. Wind turbine blades are very, very useful, very impressive technology, but after some time, it exceeds its design life and has to be brought down, has to be replaced with new blades, and then thought has to be given to the problem of how to manage what to do with these materials. So I'm proposing here, and in a subsequent clip, you hear about what I'd like to do using these materials. So thank you very much. My proposal for end of life composites is to use them in the production of customized composite manhole covers to replace metal manhole covers that have been vandalized in Nigeria. This is a serious problem. Metal manhole covers are valued for the metal they're made of. For some reason, there are vandals and hoodlums who specialize in stealing metal objects, from vandalizing railway tracks and components of railway tracks to vandalizing handrails and guardrails and so on and so forth. Composite manhole covers are very attractive to these thieves because a single manhole cover can yield a large quantity of metal which they can sell and receive some money for. The advantage of using composites in the production of these manhole covers and similar products is that they are unattractive to these thieves because they do not have a scrap value in the market. They cannot be remelted or resold to, earn some money. And so they will be unattractive to criminals who engage in these types of activities. So this is why my proposal is to use these end-of-life composites in the production of these types of manhole covers, because eventually, over time, the hoodlums are going to take all of the metal ones. That's just a fact. If you take a look at different routes in Lagos, you'll see manhole covers. You see a few that are still in place. Maybe the thieves have not been able to pry them away, but you'll see a very large number, and that number keeps growing day by day. A very large number of vandalized manhole covers that have become safety problems on the road. Vehicles unsuspectingly get stuck in these holes. These holes can cause accidents, damage vehicles, and are generally a safety hazard. People can even fall into them, which happens quite a bit. So, an alternative to these metal manhole covers would be to use polymer composites to make these components. Given the nature of the application, polymer concretes can be used in making these manhole covers, as can continuous fibers, which are more expensive, but the sorts of materials obtainable from the recycling of composites are likely to be inexpensive compared to virgin material. And that's one of the reasons why this would be a very good application of for these materials. So that's my proposal. In the past, I've made various composite manhole covers. I worked on a project for a telecom company where I created a prototype for underground fiber optic cable nodes. Um, so these were hand hole composite, polymer composite hand hole cover assembly. So it's a complex assembly allowing the connection and of fiber optic cables, allowing assembly on site, and having thick walls to withstand the conditions of use, as well as having a thick cover to withstand traffic. Of course, there are different load ratings for manhole covers, and I can design and create manhole covers conforming to each of these ratings. So I do have a few photographs of that project, as well as another manhole cover prototype that I created more recently for another purpose. There is even another manhole cover, a larger one, which I've made here. Basically, I'm in the process of making the mold of that, and I've paused that project for a while because I've had so much to do. So if there is interest in taking up the production of manhole covers using end-of-life composites, I would be very delighted to participate by designing and creating the molds, as well as producing prototypes if necessary. And if the collaborators would like to address the problem of vandalized metal manhole covers and replacing them with composite manhole covers made using end-of-life composites, it would be my pleasure to collaborate with them on that. Thank you.